Do you remember a few weeks ago, those news stories about the discovery of life in Venus's clouds? It's fair to say, we all wonder whether there's any other habitable planet in the vast expanse of space that could harbor life, and if there is, how could we find it? Well, this is certainly not easy, considering the number of factors that go into making a celestial body generous to life. But scientists increasingly suspect that the barrier for habitability is a lot lower than we had thought. It may be that extremophile life, even if it's just the most primitive microbes or self-replicating molecules, can survive in conditions that seem impossible to us. Through studies into exoplanetary science and astrobiology, we've been edging closer and closer to a breakthrough which could yield the discovery of extraterrestrial life, and we're setting new records every day. To begin with, humans have already set foot on the Moon, and the next target remains to send humans to Mars, a planet we've been exploring with satellites and land rovers for decades. We've found possible traces of life and evidence that Mars could easily have hosted complex life forms billions of years ago. But what about Venus, the morning and evening star? It too is a neighboring planet of Earth and resembles our home planet in size and gravitational conditions. With the thick atmosphere it possesses, it may be possible for some organisms to survive and evolve in the clouds of Venus. For many years, scientists thought life would be impossible on Venus, and it's not hard to understand why. We call it Earth's evil twin. That was until in September 2020, the James Clerk Maxwell telescope operated by the East Asian Observatory in Hawaii detected signatures of phosphine in Venus's atmosphere. This molecule is supposed to be extremely rare on other planets because in the vast majority of cases, it is synthesized by living organisms and does not appear naturally. The Atacama Large Millimeter Array in Chile is a more sensitive telescope with 45 antennas. It was immediately set to work, confirming the discovery, and the claims of phosphine's presence in the clouds of Venus was found to be true. ALMA also detected signals indicating about 20 parts per billion of phosphine in Venus's atmosphere. You may think that the discovery of just a chemical isn't very extraordinary news and cannot be linked to life existence, but to an astrobiologist, finding phosphine is like uncovering the fingerprints of a criminal to a detective, albeit fairly smudged. The answer to the importance of this discovery lives in the chemical composition itself. Phosphine is not commonly found anywhere. On Earth, phosphine is produced in industrial practices and naturally synthesized by bacteria when they anaerobically respirate. Now, we're pretty sure there aren't any factories on Venus, and as far as we can tell, there probably aren't any chemical processes in Venus's clouds that could yield phosphine, so that narrows it down to microbes. The concentration of phosphine discovered is much greater than what could be produced by non-living processes. Given this data, the presence of life on Venus seems probable. But nothing can be said for sure at this moment. To get a solid confirmation, we'll have to go to Venus ourselves. Well, send a scientific spacecraft, that is. United States Mariner 2 was the first space probe mission to conduct a successful encounter of the planet Venus in 1962. After traveling for 110 days, the spacecraft reached its closest approach to Venus on December 14th with a distance of about 35,000 kilometers between the craft and the planet. The mission's objective was to conduct 6 experiments and to evaluate the conditions out there. Mariner 2 made several important discoveries. Firstly, it found that Venus was excellent at distributing the heat it absorbed from the greenhouse effect across the surface of the planet. The magnetometer equipment on Mariner 2 also found that Venus had a prominent magnetic field that protected it from solar wind and radiation. After Mariner 2, there was a race between the U.S. and the USSR to put a spacecraft on the surface of Venus to examine the conditions on the ground. In 1966, the Soviet Venera lander became the first craft to crash into the surface of Venus and collect some valuable data on the way. It was followed by Venera 4 in 1967, which managed to operate its scientific equipment and take a lot of useful measurements of Venus's atmosphere and weather conditions. After these partially successful visits to Venus, the USSR sent several more probes to Venus to add to a growing body of knowledge about its composition and atmosphere. There have been a further dozen or so missions so far carried out by the US, Soviet Union, EU, and Japan. Each encounter with Venus has contributed fantastic scientific data to our repository. For example, we now know that the ground on Venus is intensely volcanic, and the sulfur in the atmosphere may indicate that there have been recent major eruptions. About 80% of the Venusian surface is covered by smooth volcanic plains separated by wrinkle ridges. On the surface, temperatures are hotter than Mercury at a toasty 462 degrees Celsius, thanks to the thick greenhouse gases in Venus's atmosphere, which have helped trap heat. With an atmospheric pressure 92 times that of Earth's, its clouds are made of 96.5% carbon dioxide and 3.5% nitrogen, with traces of other gases like choking sulfur dioxide. These clouds of sulfuric acids hover over the atmosphere of Venus and reflect about 90% of the incoming sunlight, meaning the surface of Venus is darker than Earth's, even though the planet is closer to the Sun. All of this doesn't exactly point towards Venus being a comfortable place to live, but of course, things change. The big question remains: is there life on Venus, and how will we find it? Venus resembles Earth, and that has made it a hot topic in astrobiology recently, as well as the Phosphine Discovery. With several space missions, we could confirm that the phosphine in Venus's clouds is indeed being produced by microbes. In October, a joint space mission between ESA and JAXA called BeppyColombo passed by Venus, coincidentally right after the famous Phosphine Discovery. It managed to collect a good deal of data about the cloud cover on Venus, atmospheric composition, temperatures, and the magnetic forces around the planet. These details can be used to figure out if life could evolve in Venus's clouds. There is a second flyby planned for August 2021, which could feed even more crucial information into our understanding of Venus. California-based space agency Rocket Lab has announced that they're aiming for a mission to Venus in 2023 to give some more conclusive answers as to whether there really is life in her clouds. NASA has proposed a mission called Veritas, which could verify if the atmospheric conditions are habitable for extremophile life. India, meanwhile, is working on a craft they call the Chakrayan-1, which will carry a number of experimental tools to analyze the atmosphere. There are also several private missions which have been proposed, and engineers are toying with ways to get spacecraft to Venus as quickly as possible. The window for inserting into orbit around Venus only arrives once every 19 months, meaning that these space agencies will have to work their socks off to get a mission there when they have the chance. But hopefully, when that happens, the data and information we get back will give us a desperately needed answer. Is there life on Venus? Yes or no? If you want to see more videos about space exploration and astrobiology, you can subscribe to 26 Dimensions by clicking below or hitting the icon here. You can also see all my videos about space travel and astrophysics in this playlist, which is also linked below. Please consider leaving a thumbs up if you enjoyed this video, and thanks for watching.